A researcher reports that the average salary of assistant professors at four-year colleges is more than $72,000. A sample of 1,056 assistant professors has a mean salary of $72,460 and a standard deviation of $11,230. At alpha equals 0.05, test the researcher's claim. We always begin by stating the claim and the complement to the problem. The claim is that assistant professors make more than $72,000. So our symbol is mu is greater than 72,000. The complement to this is the opposite. So the opposite is the mean is less than or equal to 72,000. Notice that the claim does not have the equal symbol, so the complement must have the equal symbol. They have to be opposites of each other. Step 1, we have to state the null hypothesis and the alternative hypothesis. The null hypothesis is always the one with the equal symbol, so the mean is less than or equal to 72,000. On your homework, they will always use an equal symbol, but if we're doing it by hand, we should use the less than or equal symbol so that these are opposites and they are complements of each other. The alternative hypothesis is the claim. The mean is greater than 72,000. Notice that in the alternative hypothesis we have a greater than symbol. So this is a one-tailed test. I'm going to reject the null hypothesis if it is too high above 72,000. So we do not need to double the p-value since it's a one-tailed test. In step 2, we'll just have to state alpha. Alpha is 0.05. Step 3, I'm going to decide if I use Z or T. That depends on the degrees of freedom. In our problem, we have 1,056 assistant professors, and minus 1 gives us a degree of freedom of 1,055, and that is clearly greater than 1,000. So we're going to use Z in step 3, Z. The formula for Z is equal to x bar minus mu divided by S over the square root of n. X bar is the sample mean, and we have that the sample mean was 72,460. The mean is 72,000. The standard deviation is 11,230. And the sample size, we know 1,056 assistant professors. Plugging in the values for Z, X bar is 72,460, minus the mean, 72,000, divided by 11,230 for the standard deviation, and divide that by the square root of 1,056. This gives us a Z statistic of 1.331. If you're having trouble getting this output of 1.331, make sure you put parentheses around the numerator and parentheses around the denominator so that you get the output of 1.331. In step 4, we are looking for the p-value. Since we're using z, we'll use our z table to find the p-value. And recall that the alternative hypothesis was the mean is greater than 7,200. So we're looking for the area to the right. We're looking for the area to the right, and we'll use our z table to find that. The z statistic from earlier was 1.331. So the p-value is equal to the probability that z is greater than 1.331. Using our z table, we get this is 1 minus 0.9082. Remember, I have to subtract from 1 because this is the area to the right. Since it's the area to the right, we have to subtract from 1, and this number is obtained from the z table. 1 minus 0.9082 yields a value of 0.0918. So this is our p-value. And again, we do not need to double it because this is a one-tailed test. Step 5, we will state our conclusion. I always ask, is the p-value less than alpha? Our p-value from step 4 was equal to 0.0918. Is that less than alpha, which is 0.05? Is that less than alpha? 0.0918 is not less than alpha, which is 0.05. So the p-value is not less than alpha. Since the p-value is not less than alpha, we do not reject the null hypothesis. There is not enough evidence to conclude. And we always make our conclusions in terms of HA. HA was the mean is more than $72,000. So we're going to say we do not reject the null hypothesis. There is not enough evidence to conclude the mean is greater than $72,000. A good tip to remember is if you do not reject the null hypothesis, then you're going to say there's not enough evidence to conclude the alternative. If you do reject the null hypothesis, then I would say there is enough evidence to conclude the alternative. So that's a good tip to remember if you're having a hard time stating your conclusion. Let's try the problem on StatCrunch. Trying the problem on StatCrunch now. Go to Stats, T-Stats. Again, we always use T-Stats if we're using technology. Stats, T-Stats, one sample with summary. The sample mean is 72,460. The standard deviation, 11,230. Sample size, 1,056. And on homework and StatCrunch, they always use the equal symbol for the null hypothesis. We're going to replace this value with 72,000 and change the alternative hypothesis to greater than. Press compute. And our t-stat is exactly the same, 1.331, and our p-value 0.0917, which is close enough to our answer. Now, we need to try the problem on the computer because most of you are going to use the computer for your homework. Now, I need to select the calculator that says hypothesis test for a population mean given statistics calculator. And let's enter the sample standard deviation, and that was 11,230. We know the sample mean is 72,460. The sample size, 1,056. And mu is 7,200. For the alternative hypothesis, we have the mean is greater than 72,000, so we're going to select greater than, and we'll select calculate, and here's our test statistic, 1.33, and our p-value is 0.09. Again, just a reminder, if you're using technology, always use T. If you're doing it by hand, you would have to use Z because the degrees of freedom is greater than 1,000.